I welcome Mr. Brian Matthews, who holds a postgraduate degree in nuclear physics with over 23 years of experience in advanced nuclear energy systems design and analysis, as well as advanced manufacturing for a wide range of industries and applications. A proven successful startup entrepreneur. He co-founded a global additive manufacturing company, Meltio, in 2019. He is the Chief Technology and Innovations Officer for Meltio and oversees the R&D, special projects, and technology incubation activities of the company. I welcome Mr. Brian, who has come all the way from US to grace us today with his presence and share his insights about additive manufacturing. With a round of applause, please.
Okay, thank you everyone. Good afternoon. Thank you to Mr. Ravi Raghavan for the kind invitation to be here. Congratulations to the entire BFW team. I think the work that has been done that I've seen in the past couple of days has been really quite spectacular. So a big congratulations. I've got a few things to say, mainly about the technology. I'm a technologist. My heart is always in technology, and I think technology is something it's like magic. You know, when it works, it's very special. And technology has always difficult beginnings, and it's like the old adage that everything is impossible until it's done, and then it's easy, right? So it's the same thing with this technology. I think the additive manufacturing industry, if you look at it today, it's a really large potential. Really, we're at the beginning of that sort of S-curve of technology adoption. The global industry today is only 10 to 15 billion US dollars. The projection for the next 3 years is to get to about $50 billion. But even then, that's a really tiny fraction. If you look at the global manufacturing market for metal, just all processes, subtractive, metal forming, additive, everything combined is about $5 trillion. So even in 3-4 years from now, with this rapid growth, we're only still at 1%. So it's really quite spectacular when you think of those statistics. I think these machines you see to your right are really wonderful manifestations of the technology. The technology Meltio has developed over the last several years has been really from the ground up. And that's why I very much like the work that's been done here with the BFW team. By really no compromises. The machines you see here have been built from the ground up around the technology, and that's something you don't normally see in the industry. When I travel the world a lot and I see a lot of great products, but most of the products I see are sort of technology compromises. When you compromise a product to work with another product, you don't get this elegant solution. Oh, sorry. So, so with that said, I think these products are really fantastically engineered, and I think in this market they're going to do exceedingly well. When I look forward to the sort of trends in the industry, I think there's no question that there's going to be a greater market share for what we call DED. DED is sort of directed energy deposition. What's unique about this process is that we use a laser source, but we use multiple laser sources. And that gives us an interesting architecture where we can have the material feed on axis, which is really crucial for having excellent material properties and geometrical capabilities. I love the name of the product, Photon. I think that's a brilliant move. Because really that's what we're doing. We're engineering products with the basic quanta of energy, which is light. So yeah, I really love the product name. I wish I'd thought of that. The technology is DED laser-based, and I think what we're going to see is that DED is going to grow the market share in metal AM, and metal AM is going to grow its market share in traditional manufacturing. So you've got these two growth curves. I think the interesting thing for the technology, because it's been built around sort of first principles approach, when you have a first principle mindset, you're looking at everything from what is the cost of the machine? What is the cost of using the machine? What are the consumables costs? how easy is it to use the machine? What is the quality of the part? You look at all these sort of what I call friction points, barriers to adoption. And what we've tried to do is to really optimize the technology to break down all those barriers. So a metal wire process is really unique in that regard because 100% of the material ends up in the part. Now in a hybrid system, yes, there's a very small minor amount of material removal to get to the final shape, but the fraction of material utilization is extremely high, and most other processes don't have that characteristic. Also, metal wire is close to commodity material price. So I think when you look at it from that first principle mindset, it's very difficult to beat this process on cost. And that's crucial for moving forward and getting to this volume strategy, because like BFW, Meltio has a volume mindset. So we want to keep costs low, we want to make the machine easy to use, and make it open and accessible. I think the other characteristic of the technology, that's something that we haven't spoke about today, but I find really fascinating, is multi-material. So this technology is capable of using more than one material in the same part. And that has really fascinating applications that you don't normally see in industry, because the mindset for design has been you have a part, you have a geometry, and you build it out of one material. And because that's the way manufacturing's been done in the past, there hasn't been the tools to put different materials into the same part. So with this technology, you can add two materials in the same part, and that allows you to have either a performance advantage or a cost advantage, or both. We recently demonstrated some applications where we manufactured aircraft turbine blades, which are normally alloy 718 parts, and we achieved the same result with manufacturing the blade from stainless steel, and like 98% of the mass was stainless steel, and only 2% of the mass was alloy 718, and we just put the 718 where it's really needed, that sort of leading edge of the blade. So you end up with a part that performs the same, but the cost is 5-6 times lower cost. So I think this type of technology is going to change the way people think about design, and in the future there's going to be multi-material parts will be almost like a standard consideration. It won't be something you see just done for research and development. It's going to be done for mass production. So yeah, sorry, don't want to bore you too much with the details of the technology. It's an honor to be here. It's my first time in the country. My father was born in this country, so for me it's an emotional connection to come here for the first time. And so I hope I have many more opportunities to visit. Again, congratulations on a wonderful event. I think the team here are incredible, very hardworking, and it's great to be with you all. Thank you.